So it says that a student plans a two-step synthesis starting with phenylamine, and it's got the steps in the synthesis shown below. And it says in step 1, phenylamine reacts with ethanoic anhydride to make a compound and one other organic product. So, although you may be able to recall ethanoic anhydride, you can deduce its structure from the structure of compound A. So let's look at the difference between compound A and phenylamine. So a hydrogen in the amine group attached to the benzene ring has been replaced by C double bond O with a methyl group attached to it. Sometimes it helps just to think through what's changed. So what sort of compounds have you seen that have a methyl group attached to a C double bond O? So if you cast your mind back, hopefully you might come up with things like this. Now the problem with these three structures is although they contain what we're looking for, the problem is once they've reacted and that's been substituted on, there's nothing much left to create the other organic product with. So you have to have something that is big enough to have one of those structures contained within it, but also have enough left over to create another organic product. So one candidate is our friend ethanoic anhydride. So if we now take one of those structures off an ethanoic anhydride molecule, we can deduce what the other organic product left might be, which gives us ethanoic acid. Okay, let's move on to the next part now. So I've emphasised the 5 marks for part 3, and this part is taking the recall of your standard aromatics knowledge that you were taught and hopefully went away and learned, and then applying it to a new aromatic compound. So if your recall is strong, you have a good chance of getting most, if not all, of the 5 marks. So it's worth making sure your recall of aromatics is good. I said it like that because it's a really easy one to get. And if you're still struggling with aromatics recall by the end of the 2nd year, something's gone wrong somewhere with the way you've been studying, because it's not difficult to get. So let's go through what you need to do. So this is why your teachers always say to read the question. You need to make sure you read the instructions and process them before beginning. So let's do that before we even start. It says outline with the aid of curly arrows the mechanism for the conversion of compound A into compound B. So looking at the two compounds, nothing's actually changed apart from the substitution of a nitro group at position number 6. So therefore this is simple electrophilic substitution. Now it's fair to say that most people were able to work that fact out and start to produce something. However, again, if you haven't done the recall, you're going to get your curly arrows all mixed up, you're going to forget to put them in the right place, and you're going to point them in the wrong direction. So again, this is recall of a simple mechanism that we covered in summer's teaching. Admittedly, yes, it was whilst you were learning remotely, but it's a simple case of going to the textbook, getting out your flashcard, and doing that look, cover, write, check, repeat again, if this was a question where you lost marks. And it also says in the instructions, use equations to explain how sulfuric acid acts as a catalyst in this reaction. So in other words, an equation showing the sulfuric acid making the electrophile, and a separate one at the end showing the sulfuric acid being regenerated is needed. So I've put the electrophile in blue just to emphasize it, and I've put the positive charge on the nitrogen for reasons I'll explain in a second. So now we can start with the mechanism. So as we go, I'm going to highlight the key features that you should have in your mechanism. The curly arrow starts in the circle and comes out towards the nitrogen atom close to the point of substitution, which is in this case position number 6. So the next thing you have to do in the second stage is to draw out your intermediate. So that has a couple of marks attached to it, and you've got to get them both spot on. So first of all, I've put the nitro group substituting. In order for that to happen, this carbon-hydrogen bond at position number 6 has to break. So a curly arrow has to point into your newly formed partially delocalized pi system. So your product, or products I should say, both need to be included. So your newly substituted or nitrated structure and the proton, or H+, that the substituted hydrogen atom has now become. Because remember, we broke a carbon-hydrogen bond, didn't we? That hydrogen doesn't just disappear, it turns into a proton, which comes off. So now we can do our regeneration of our catalyst. So reminding ourselves that the first equation was making the electrophile, you can take the H+ that you've just made and react it with the HSO4 side product in the making the electrophile equation to regenerate your sulfuric acid catalyst.